Hey everybody, it's John again with GPMech, where we help you go faster, faster. So if you've been to our site before, gpmech.com, and you've gone to our gearing app, then you know that you can display the available torque a bike has and the available acceleration a bike has by changing a bunch of parameters about that vehicle. And you probably also know, if I move this over, move myself over there, that you can add a vehicle. But currently we only have a few vehicles available. They're all Yamaha. So chances are you might want to create your own vehicle. That's what we're going to do today. So what better vehicle to create than a 2025 Ducati Panigale V4. So we're going to start with just going ahead and Googling the vehicle, and we can ask for transmission ratios or statistics about the vehicle, and chances are you're going to end up finding some page like this, some manufacturer's page or dealership page, where it will tell you all of the information you need to know to build your model. So I'm going to take this page, which has our information, and I'm going to put it side by side with our app. And I'm going to change this to 2025 Ducati Panigale V4R. And let's change this to a more Ducati red. Okay, then we are going to go into our model here, and the first thing that we want to do is enter a tire diameter. So on our statistics page, we're going to look for tire size. So we see that our rear tire is a 260 ZR17. Now, I don't know exactly what the outside diameter of that tire is, but I can enter the tire size directly and put in a 260 R17, and it's going to calculate it out to about 672 millimeters. Click apply, and then we've got that dimension right there. So the next thing we need is the vehicle mass. In this case, it's saying the dry weight is 191. Gotta be a little bit careful with these dry weights. Sometimes that doesn't include fuel or oil or anything like that, but for the purposes of building the model, it's a great place to start. And rider mass, this can either be your mass or your rider's mass, or whichever rider you're trying to model. So in my case, I'll put in 83 kilograms. And again, with drag area, we're probably not going to know what this is for our particular bike unless you work for the bike manufacturer. And then if you are, I'm really happy you're using my tool. But if you don't know your drag area, leaving it at 0.35 is a great place to set it. The next big point that we need to fill in is the primary drive and transmission. So this controls your initial reduction in the clutch as well as all the gears on your bike. So this information sometimes can be a bit difficult to find, but thankfully for the Ducati, they list all this information here. Another great source for this is you can check ChatGPT or Copilot. Sometimes it'll get you good information, but you might want to double check that. If you have a bike's owner's manual, there's also usually a specification section where it lists all of the available gear ratios. In our case, we've got all the information that we need right here. So we're going to start with our primary drive. So this is going to be the connection directly from the crankshaft onto the clutch, and in this case it's going to be 80:1. And for the gears, we're going to have the first gear is 3615. You can either enter these directly like we're doing, or you could start with a completely fresh bike and add them all yourself. In this case, it's easier for me to just start directly from the previous bike that we had here. So 3417. Third gear is going to be a 3319. Fourth gear is going to be a 3221. Fifth gear is going to be 3022. You can see these gears are close to what we had before, but not exactly. And finally a 2722. And our final drive, which is our chain front and rear sprockets, is going to be a 1641. So 4116, that's the exact same that we had from our previous bike. Now you can minimize the transmission and gears since they're in there, and if you want to check the overall ratios, I think that there might be something wrong about this ratio, the primary drive, because it's giving us numbers that are just way too high. So let me take a look at the other source of information. This is why it's great to have a few different sources of information, because you never know if you can exactly trust the information that's given. So 1.8, 1.8 to 1. So in that case, primary drive, we're just going to enter the ratio directly as a 1.8. It's not giving us the actual number of teeth. And then these gear ratios make a lot more sense. We start out around 10 and go down to about 5.5 overall. So that fits a lot more with the other bikes that I've seen. So then this is the part that gets a little tricky. We are going to need a dyno curve. And if you have your bike and you have your dyno curve directly from whoever is running the dyno for you, that's great. And you can just browse and upload that here. But in our case, we don't have that information. So I'm going to close this and this. And I had opened up a dyno window before. So I was able to find this information online, which has a few different dyno pulls from this bike when it came out. So it's got the stock curve as well as some aftermarket accessories fitted. So this would be a great thing to compare too. You maybe want to compare what the stock bike is and see if the upgrades are actually worth it. See what kind of acceleration difference you're going to get from spending all that money. Maybe we can do another video on the difference between an initial dyno curve and the final dyno curve. But in our case today, we're just going to pick one of these graphs, and I've already got one downloaded. So I'm going to introduce you to another tool, and this is going to have to go full screen. So this tool is called WebPlot Digitizer, and it's a great way to be able to pull information out of any kind of graph that you see online. And so in our case, the way to find it is a little tricky. I always just Google WebPlot Digitizer, and then you're going to have this pop up, and I always use the V4, the old archived version. So then if you click version 4 here, it takes you to the online version, and now we can load our image, and we'll go to my downloads, and we will open this file. So what we've got in this case is a 2D XY plot, and we're going to click Align Axes. Then it gives you some instructions. Basically, you need to pick 2 points and tell it what the values of those points are. 2 points on the X and 2 points on the Y axis. So we will go ahead. I like to pick a value that's on the lower end. So you can see here, this is RPM along the X axis. So if I line this up right around the 4,000 mark, if you look at the top right corner, you'll see we get a little zoom view. So I can get it lined right up on the axis. That's going to be my first X. And then we're going to go maybe a little bit past peak power. So we're going to want to get, you can see the dotted line there, and if we click on the dotted line, that'll be our second x-axis. And now for us, we want to use torque as our reading, so that's going to be this lower curve here. And so we're going to want to go from the lower end of torque, which is 40 foot-pounds here, and to just above the upper end. Actually, we can, yeah, we'll go a little bit higher. The further apart you get, the smaller the tiny little differences in where your mouse is placed make. So we'll go to 100 there. And then we'll click complete. And now we just have to tell it what those values are. So we got 4,000, 14,000, 40, and 100 for our values. So 4,000 and 14,000 on the x-axis, and then 40 and 100 on the y-axis. 4, 14, 40, 100. Okay, we don't want to check log scale because this is not log scale, and we will click OK. So now we've got those points set. I'll move myself over here, and what we want to do is we want to try and extract this data. So in our case, what we want to extract is this blue curve here for torque. That is our new value. So what we're going to do is we can filter colors. So if you click on this color box, it'll open this up, and it kind of gives you a preview of the main colors that it thinks are in the graph here. And so I'm going to say we're probably pretty close to this blue. We'll click done. And then you can specify the distance you want to weigh. So colors are, colors have a certain distance that they can be filtered. But for now, we'll just leave it at the default value, and if we need to adjust it, we will. The other thing I want to do is I want to mask. So I'm going to take a pen, and I'm just going to draw a highlight over top of the area that we think we want to get our data from. And I'm going to stop right there at the crossover and draw that again. Actually, we'll go straight over the crossover, and then I'll erase with a slightly smaller pen. So I'm trying to erase away the power curve so we don't get that data there. and maybe over by this arrow here as well. Okay, so now I'm just going to click run and see what happens. So you can see these are the data points that it selected, and it did a pretty reasonable job. It's missing a couple in here, but that should still be plenty for us to get data from, and the curve looks pretty smooth. If you did end up with a point somewhere out of the range that just doesn't look like it fits, you can go ahead and use more of that box or pen or erase to try and get that to work. So, and we could add manual points. I'm actually going to expand the distance away a little bit and just see. That does grab those few extra points that we had, but it added some that we don't want. So what if we drop it down to 130? And that looks pretty darn close. Let's go 130, and then maybe we just want to delete this one point here. It doesn't quite look like it fits. Okay, we have good data. We can then specify if we want it to go every certain number of RPMs. So I changed this from averaging window to a step, and let's say we want data every 500 RPM between our two values, and we'll click run. Let's bring the RPMs down to 2000, and we'll go every 250 RPM. And max value, we'll get some extra in there. I'm not sure why we lost this low end stuff, but for a racing model, we're never really going to be below that 6,000 RPM spot. So I'm pretty happy with that. Now what we're going to do is we will download this data, and the download button. So we're going to click view data over here, and we don't need all these data points. So what we're going to do is probably 2 data points is plenty. We will format our data. So we got our RPMs, which we don't need even the 2 decimal points, but I don't think we can sort those individually. And then we have 2 decimal points for our torque values. That's great. We're going to download the CSV, and if we just go to our folder, and I'm going to rename this and our downloads to 2025 Ducati Panigale V4R. Now we can go back to the tool that we built at GPMech, and we'll look for some motor data. So we'll click Browse, go to our downloads, and pick that torque curve. We'll click OK, and you'll notice we start to get some information here. So we've got 2 columns in this data. The first one, in our case, there is no data labels, but we know that it's engine speed in RPMs. And the second column is going to be our torque, and that was in, I believe, foot-pounds. Let's confirm with the graph. Yep, torque in foot-pounds. So we're going to have English units. You can enter either unit you want. So torque in foot-pounds, and here's our graph to confirm. We have one point that looks a little bit out of place here. So we might want to fix that, but it looks good enough for what we're trying to do. So we'll click Accept Data, and now we have our torque and power curve for our Ducati here, as well as our output torque versus speed and our acceleration versus speed. So this is great. We have just entered a new bike. Now we might want to compare this, and since this is a 1000cc bike, let's compare it to a Yamaha R1. And we can add a Yamaha R1 in there, and we can see just the difference that we have in available torque between those 2 bikes. If we look at acceleration though, we'll notice that the bikes are actually pretty close. So even though that Ducati has a lot more torque at the rear wheel, with the way that the Yamaha is set up, we actually end up having very similar acceleration between those 2 bikes. And that might be a weight difference. So we have about 10 kilos less of weight from the bike and the rider as well. Let's put me on both bikes. Yeah, so we end up with very similar accelerations in the low end, and then throughout the speed range, if we look, we notice that the Ducati is able to get a little bit more acceleration at each speed. So in first gear, at about 140 kilometers an hour, the Ducati is able to pull 1.2 Gs, whereas the Yamaha is only able to pull 1.1. So that's kind of similar to what we would expect to see. So I hope this has been helpful. I hope this has shown you how you're able to create a new bike and how you're able to compare that to other bikes, and hopefully that helps you make some decisions. Like I mentioned before, we had 2 torque graphs for that Ducati, so we could compare the stock bike to the tuned bike and see if it's actually worth it to make those upgrades. How much acceleration is your money actually buying? So if that's a video you want to see, put a comment down below and hit like. Let me know that that's something that you're interested in, and we'll try and make that for you next time. Hope this has been helpful, and go try the tool. Let me know what you think.